All right. Good morning. Hope you've all had nice, restful weekends. Also, not on my house directly, but at least on the north side of Columbia, it snowed again. So, if any of that happened to you guys, I hope it was pleasant and not inconvenient. How y'all doing?
Good.
Any random questions before we get started today? Okay. Do please ask any random question at any old time. That makes my day nice. Today is January 31st. It is Monday. This is going to be a normal week for us, so we do have in-person lab. So come to lab as normal. Things to note, today the chapter 1 homework and quiz are due. They are physically due tonight at midnight, so after this class you will have until midnight to finish them up, at which point, additionally today I will also be putting out the chapter 2 homework and quiz, but those won't be due until next Monday, February 7th, at the earliest. One of the things I want to do today is open the floor up to any questions you guys have about the homework. There's a couple of tricky questions people have been emailing about that I do want to address. Additionally, I want to briefly talk about the quiz because it's been pointed out to me that the way I do my quizzes and what I actually had typed up in the syllabus don't match. So to those who haven't taken the quiz yet, quizzes in this class are designed to be about 2 questions each, maybe sometimes 3. It's designed to be like quick 10-minute practice. Can I do this in a technical time crunch without needing my notes? And when this particular quiz went live, the way that Achieve works is when I create an assignment, I can do a bunch of different settings about how it's graded, what it counts as in the grade book, how many attempts do they get, a bunch of settings in the menus. And quiz 1, the chapter 1 quiz, went out with the wrong settings. It went out with settings such that I believe when a student took it, you would input your answers once, and that's it. And I think you'd find out if you were right or wrong, and then that's it. You don't get another chance. Which is not what I was wanting to do. Achieve works a little bit differently to a previous platform that I used that I was trying to emulate in the settings, but it went out with the wrong settings. That was not my intention. So for those who have already taken the quiz, I have changed the settings to one of Achieve's pre-made options that actually lets you retake it. You do it once, you get a bad score, you retake it, it reshuffles the numbers, and you can try again with slightly different numbers. So if you have already taken it and you took it once, it gave you a score you didn't like, and then it locked you out, you can now try again. You get 5 attempts, it'll scramble the numbers each time, but the goal is so that you can work on the method you use to find the answers. So, announcement, you've already taken the quiz, you can now retake it if you're unhappy with your score. As a reminder, quiz should usually be the last thing that you do. It's designed to come after the homework. So make sure both of those things are done before midnight tonight. In addition, in terms of lecturing and learning new materials today, my goal for the learning is to make sure we continue talking about Newton's laws and forces, because that's what lab is going to be about this week. So up to half the class, homework questions, and then the other half making sure we have a solid foundation for understanding the forces we're going to be examining this week. How do you guys feel about this? All right. So, that said, that's not right. My laptop is currently in the process of being fixed, but it's more broken until it gets fully fixed. And I need to use the broken one because I don't have a second one yet, so literally this screen is dead and I'm having to fish the tabs from the second screen in the darkness. Not the best, but it will be fixed by the end of the week. So this is all the questions on the homework. We can take a look at as many as you guys need to. Is there any specific things that you guys have in mind?
Question 4.
Question 4. Yes. This one, I will admit, is problematic in its phrasing at times. There's two elements to this that seem designed to trick people, which I'm not a fan of, admittedly. We have ants moving back and forth along a linear path. This is one-dimensional, so we just have ant hill, and then ant hill is some distance away from, yes, food. I'm just going to call it food. Problem tells us we have ant hill, which is some distance away from food. Your numbers will be different. The first, I call it trick, that this particular problem gives you is it does tell you, why is this one bigger? It does tell you how far your anthill is from your food. The numbers that I currently have up here is 3.3 meters, sorry, 3.5 meters, my mistake. It then says that there is a specific ant that is going to be walking back and forth along this trail. That ant, the ant falls unconscious. Okay. An ant from the hill begins walking back and forth along the trail, trying to bring food back to the ant hill. And we know the time that that whole process takes. So, T is some amount of time. You do have that number. And eventually the ant will collapse, and you will specifically know where the ant collapses. You'll be told some distance from the ant hill. My current numbers are 1.4 meters. This drawing is not to scale. And you'll be asked, what is the ant's average velocity in regards to the entrance of the column is the origin of the positive. After looking at what the system views as the correct answer, what the system is wanting you to do is determine the average velocity from the food to this spot if it took the ant this long to get there. Now, some of the weirdness here has to do with how some textbooks define average velocity. Average velocity is total displacement divided by total time. It doesn't exactly matter how many steps you took. It cares about where you are versus where you began and how long it took you to get there. For example, if you were going on a big hiking trip, you started here and you walked a huge load of trail, and it took you like 3 hours to go like all of these miles. If you start and stop here at the same place, your displacement is 0. So your average velocity is 0. Obviously that doesn't measure your walking speed, but that does tell you where you end up after that amount of time. And that's the viewpoint this question is taking. It wants to know basically this distance divided by this time. I admit this particular question is not exactly my favorite, so I'm glad you asked. So, V equals delta x over delta t. Timer begins as the ant was here and ends here, so this is our time, and our change in displacement will be the total distance minus this one. Actually, reverse that, because delta x is always final minus initial. So using my numbers, the final position is the spot of collapse close to the hill, and it's registering the initial position as at the food that the ant found. And because the ant was moving in what is typically considered the negative x direction, going from the food back to this spot, one of the issues that I have encountered, that I've seen people have, just getting questions emailed to me over the weekend, is that Achieve wants a negative answer. Specifically because you are, it says, defining the entrance of the colony as the origin and the positive direction towards the picnic table. So this way is positive, and going from the food to here would be the negative direction. The more I think about it, the more I explain this one to people, the less I like this question. And so I'm going to probably not give this one again, frankly. Question?
So how similar are your test questions going to be to these questions?
I don't like this one. Normally, in this case, I try to give you a picture and make what I'm asking a lot clearer.
So you'll like include a picture and it will be like clear kind of the directionality and stuff? Because I was like getting all mixed up on that one. And
this one I have now come to really not like. So I would not write one like this at all. In fact, if some people hadn't already finished the assignment and gotten points for this question, I'd probably remove it. But I will make sure that all future assignments are far clearer. On tests, either I will give you a picture or part of the problem will be creating one.
So like, if you add up the time the total he traveled and like whenever he dropped, it doesn't equal the whole length of the thing. It's usually less. Because right now I have them 1.8 and 1.7.
Yes, you're right. Which is, you're correct. This number, whenever I've calculated students' correct answers, this number never seems to actually factor in. I'm not sure why it's there, if I'm honest with you. It kind of seems like the designers threw in another number just to get people confused, which I don't like. Again, that's why I'm not going to ask this one ever again.
I was just going to say the conclusion I came to is that the 1.4 is him just staggering back and forth, and he falls unconscious at 1.9. So that's the number, the 1.9 is the number they want you to use, and the 1.4 is him just staggering back and forth and not where he actually, that's not the distance he actually goes, I think.
Yeah.
And that's like what's confusing about it, is that they're just adding it in there adding it in there to confuse you.
Exactly. This is a red herring number, and I don't like that.
They want you to understand that he's just like going off the path.
It's like he got here and then he started wandering in circles for a while.
Yeah.
And then he fell over.
Okay.
That took me forever to figure out, but once I did, I was like, oh.
So, I don't like this question. Please do copy down how to find the answer. Yes.
I don't know if I'm like missing something, but I at least probably a bunch of times lost my answer just now, and none of my answers are correct, so I don't really know if I'm missing something.
I can look at people's individual versions and calculations at the end of class. I would very much like to make sure that you get the correct number. So at the end, if you want to bring your laptop up, we can take a look.
Could we do question 5?
5 is that? Yeah, I've gotten questions about this one. I'm glad you asked. 4 is poorly written. 4 is hard because it's poorly written. For that, I apologize. 5 is designed to be like how on tests there's usually like the hardest one at the end. It's not at the end on this assignment. This is designed to be the trickiest one, and if you think about it, if the trickiest one is 10% of your grade, you can still get it somewhere between an 80 or a 90 if you don't necessarily get this one. So this is the hard one. It still uses all the same principles, just in a unique kind of way. The physical setup here is ball being dropped from high up, and it's going to pass a window as it falls. And this is all happening from the perspective of Tom, who is inside the apartment with this window. From Tom's perspective, all Tom sees is the ball pass the top of the window and then zoom down to the bottom of the window. So Tom's frame of reference tells him that the ball zooms past his 1.2 meter tall window in 0.190 seconds. That is all the information that Tom definitively has about this thing. He doesn't know how high it was dropped from, and he doesn't know how fast it was moving. All he knows is it covered this distance in this amount of time. Now this is a falling object, so all of our conclusions we can make about projectiles, falling objects still apply. It's going to accelerate towards the ground at negative 9.8 meters per second squared. As soon as the ball drops, it is accelerating at that rate. So we automatically have this piece of information as well. Now, this one's a logic puzzle. And to get to the correct answer, you need to think about it in two distinct stages. This question has ultimately two parts to it. And you have to do the second part before you can do the first part. I will elaborate. In chronological order, the events from start to finish, the ball starts from some height. And as it falls, it's going to accelerate to some unknown velocity. We don't know from how high, so we don't exactly know to what speed it will accelerate. But assuming it was dropped, its initial velocity is 0, and then down here, after falling some distance h, it will accelerate to some unknown final velocity. So at this point, the moment before it passes the window, it is accelerated as it falls this distance. We don't know the distance, we don't know to what velocity, but we do know this would happen. After it passes the window, we know that it covers this distance in this amount of time. We don't necessarily know how fast it was going at the start or the end of that process, but we know however fast it was going, it will continue accelerating, and it covered this distance in this time. So this, the Tom's window portion, is chronologically the second half. And we don't know h, we don't know how long it took the ball to get to Tom's window, so part one's kind of an enigma right now. But what part two can tell us is, we can use part two to figure out how fast the ball was moving at the start of Tom's window. And the speed at the start of Tom's window is the speed at the end of the first part. How does that feel so far? So if we look at this as two distinct sections of time, the final velocity for the first chunk will equal the initial velocity for the second chunk as we go from one to the next. So if we figure out the initial velocity of chunk 2, that'll be the final velocity of chunk 1. which we can then go back here and try to figure out how high it would have fallen from to get to that speed. How do we feel? It is okay if this does not make much, if you want me to rephrase this, if you need a different explanation, I will absolutely do that, I just need to know.
Wait, so how'd you get, 1.9?
Oh, the time? This is the time specifically to fall past the window, and that is given in the question. I admit, it's a little hard to read because of the metal strip.
So what's the answer?
I haven't solved for it
Oh,
yet.
my bad.
I have not done any math yet, I'm just explaining setup. As for math, we need to start again with this second part. We're starting with Tom's window. At Tom's window, we know the ball will have some initial velocity as it continues accelerating past the window. So it has an unknown initial velocity, it is still accelerating downwards, and it covers this distance in this amount of time. So we want initial velocity, we know time, displacement, and acceleration. What formula can tell us initial velocity from those pieces of information? A little louder.
3?
Formula 3. So, I try to label all my work. Part 2 is the Tom's window part. So using the information from the second interval of time, from the Tom's window portion of this situation, we know that the ball will fall this distance. Since it's falling downwards, I'm going to make that number negative. It'll fall this distance. We don't know the speed at which it was at the top of the window, but we do know how long it took to move past the window. We also know how fast it's accelerating as it moves past the window. And so Formula 3 should be able to tell us the speed the ball was at as soon as it passes the top of the window. Same formulas, same logic as we've been using so far. Once you have this initial velocity, this would be the same number as the final velocity for the earlier point in time, for the accelerating down height h portion. We don't know how long that took, but we can figure out to what speed the ball managed to accelerate. My calculator is still missing in action. Nope, we got it. Come on now. I've done this before with other students' numbers, but now I need to check my work using these numbers. So using these numbers, the initial velocity as soon as we begin passing Tom's window should be negative 7.25. This number would now, we can use it as the final velocity for this other period of time. As it falls this unknown height h above a Tom's window, it's going to accelerate from 0 to this velocity. So for this earlier period of time, we now know Vf, Vi, A, and we want displacement, delta Y or delta, I'm gonna call it D, yeah, no, it's delta Y. We wanna know how far we fell to make that happen. So with this information, what formula will get us where we wanna go?
The fourth one.
Formula 4, one of those unique times where this is the perfect tool to use. Velocity final squared is velocity initial squared plus 2a delta displacement. Displacement is the only unknown left. So, the order of operations for your numbers and for your version, use the data from Tom's window to find the velocity at the top of the window, which is the final velocity at this other chunk after. The question asks for it in terms of h. H is the distance the ball fell to accelerate up to speed before it passed the window. And then formula 4, once you have this velocity, can get you where you want to go. Most of the answers I've seen have been coming, the range of numbers that the question uses are somewhere between about 7 to 11 meters per second for the velocity. And what that would mean for the distance is somewhere between about 2 to 4 meters usually. Oh, no, my answer's 1 9. Well, now again, your numbers are different, so hopefully this doesn't affect you, but turns out I did make a small mistake. I got my own final velocity wrong, just because of an algebra error. Yes?
In the second part, what is the velocity initial?
Assuming the ball is being dropped by someone standing on the roof, if it's being dropped just from someone's hand, its initial should be 0.
What did you say the answer range from for the second part?
Yes. For the second part, the actual final answer the question wants, I think the lowest number I've seen is 1.2. The highest number I've seen for an answer is probably about 3. So it'll depend on your randomly generated numbers. But I would expect it to be a small number, somewhere between 1 to 3. And I will also happily look at anyone's work and your unique numbers. I can load up individual students' versions from my computer. So if you're working on it tonight, if something's not working right, I can look at your numbers, calculate it through myself, and let you know what I see. 4 and 5 are definitely the ones I've been getting the most questions about, so I'm glad you guys asked. Any other big pressing issues at this moment in time? Okay. As a reminder, these are due at midnight, so you have all day. Please keep that in mind. I will also be answering your emails all day. I also have students that are going to come to my office while I'm on lunch break to talk. So all day, I'm available to you as you're finishing this up. Please do not hesitate to send me questions. Additionally, keep in mind, each individual homework and quiz is a minuscule part of your grade. There's gonna be like 10 homework assignments. Each homework assignment makes up 1% of your grade. So if you miss one question on one homework assignment, that's like 0.1, maybe 0.01% of your grade in this class. These are low stakes practice. That's all it is. Yes?
So they're both graded on accuracy and modification, right? Like, when we're getting physical accuracy and modification.
Well, the benefit of this auto grading is that you get immediate feedback. The downside is it doesn't grade for partial credit. So I am in the habit of if an assignment is done and a student didn't get something completely right, but they know that they were close, if you send me pictures of your work, I can go back in and change the score to give you like half credit. Because I want to reward you for your work. So the automated grade is only accuracy, but I can manually make it completion because I want to reward you for the work you actually did. Does that answer the question? Okay. And on tests, it's always completion, because I give you partial credit for literally everything you write on the test. And on labs. And the final. Okay. I want to switch gears and look at some Chapter 2 information to make sure everyone is set up and on equal footing when it comes to lab this week. Again, do please keep sending me any and all homework-related questions all the way through the night. I will be awake. I will get them. I will respond. Is that a question or a yawn? You are allowed to yawn. When you're a teacher, anything that remotely makes you think someone has a question will suddenly get your attention, like a dog noticing a squirrel. Teacher brain is a very strange psychosis. All right. On Friday, we began looking at Newton's laws to help dust off the cobwebs and remind ourselves of what they are, because you have definitively dealt with and heard of all of these things before. We're just going to start looking at them and doing math on them in some greater detail. And I think I ran through each of them pretty quickly. Law 1 is the law of inertia. Things tend to keep doing what they're doing until they are literally forced to change. Law 2, force equals mass times acceleration. This formula will be used constantly till the end of your science career. And law 3, for every action force, there is an equal and opposite reaction force. I could probably teach a whole class just about this one. This one has a lot of finer details to it that we will slowly unpack as we continue along. But in short, anytime one object exerts a force on a second object, object 2 exerts an equal but opposite direction force back. This happens literally every single time. If I lean on a wall, I am object A, wall is object B. I exert force on B, B exerts force back on A, but in the opposite direction. Some key things to note about this before we continue on and look at examples. It's always two objects acting on each other. It's never a case of two forces acting on one object. It's always one pushes on two, therefore two pushes on three. The forces affect different things. It's an exchange. like I said, we'll look at some more examples and start elaborating shortly. For right now, any questions about these statements as they have been presented?
Does that only apply to Earth's gravity?
Say again?
Does that only apply to Earth's gravity? Like, you know how in space, like, stuff floats around?
Which law are you referring to, sorry?
The first one.
First one. This is a universal statement. What's unique on Earth is that we always have gravity pulling us down. So there's always some force present to affect something's motion. Objects will stay at rest if the forces acting on them are balanced. For example, gravity's pulling it down and I'm holding it up. Those two forces are going to add up to 0. So the net force being 0 means this object can stay at rest. It's going to keep doing what it wants to do. Similarly, in space, where all of the forces acting on something are incredibly weak, they will also add up to 0, and an object will keep doing what it's doing. Yes, we very rarely see constant motion on Earth because of friction and because of gravity. Space is usually the only place you will see something moving in a straight line indefinitely forever until it hits something. But that is one of the reasons that space is incredibly dangerous. Literally, did I mention the bolts destroying satellites yet? Okay, good. Yeah, literally anything flying through space is functionally a weapon waiting to happen. Does that answer your original question? I'll start with that one.
Yeah.
Okay. Any others about the statements currently as presented? Yes.
What's that?
Oh, that's a great question. Thank you. This is the Greek letter sigma, which, depending on how many places on campus you've looked, you've probably seen before. In math, this means sum of, but I'm going to write that out. Are you kidding me? Ooh, 4 for 4, I think. Keeping track of this streak is only going to lead to heartbreak when I miss. So in math, sigma means sum, S-U-M, of. So in the case of this specific formula, when you have an object, literally anything, if you take all the forces acting on it and keeping in count all of those forces' directions, and add those forces together, the total force acting on something, I will commonly refer to it as the net force acting on something. The net force is what will determine its eventual acceleration. You sitting in your chairs right now aren't accelerating from our frame of reference, but there's still forces acting on you. As pointed out, Earth's gravity is constantly working, and the chairs beneath you are pushing up. Those are two distinct forces. There's forces present, so the forces aren't 0, but their sum is 0. Anything you've ever seen sitting still is not representative of an absence of force, just a balance of force. You literally cannot escape force in any corner of this universe. So, if something isn't accelerating, the force is added up to 0. If something is accelerating, the forces are imbalanced and they don't add up to 0. In the case of falling, when I let go, the force I'm exerting vanishes. Gravity is now the only force, so the force of gravity will cause the acceleration of gravity. Does that answer the question? I'll take that as a yes. Okay, this symbol will continue to come up, so do keep it in mind. I will remind you each time, but sigma equals sum of, the summation of. Now we are going to primarily be studying Newton's laws through the lens of forces. And to that end, we'll get to that. No, actually, let's do that one now. We'll do a quick sample question so that we can utilize Newton's second law, that formula we just, the formula that is the second law. This is basically four-way tug of war. We have one object being pulled in 4 different directions, or technically pulled in 2 different axes, just back and forth in each of them. So 4 different forces totally currently here, and we want to determine the component form. These are vectors, which means we can write them in terms of x, y components of the total force acting on this object, and then the total acceleration of this object. So, if this is a 4-direction tug of war, envision this is like looking down from above, from a drone's eye view, looking down on this 4-direction fight. We have 4 forces present, but those forces are divided up into 2 different axes. So in terms of the x-axis, we have 250 newtons to the right and 200 newtons to the left. And just in the x-axis, who's winning?
The right.
To the right. Not a trick question. This direction's bigger. The box is going to eventually move in that direction. And so to determine that mathematically, let's just add all the x forces together. We've got 250 newtons to the left and 200 newtons, 250 newtons to the right, 200 to the left. They are facing different signs of that one axis, and so even though we are adding them, since they point away from each other, it's functionally subtraction. The 200 points in the negative x direction, so we need to make it negative so that they actually add up to 50. Similar thing in the y-axis. We've got 100 newtons pointing upwards and 125 newtons pointing downwards. So not a trick question, who wins?
Down.
So, just looking at the forces within their own axes, this object is probably going to get pulled right and downward simultaneously. So, we could take these numbers, and if we thought of this as a typical XY graph, we could list them as a system of coordinate points. 50 in the x, negative 25 in the y. And this is now a whole answer for the force vector. It tells us specifically how much force that combined summation vector points in each direction. And now that we know that total force, we can use Newton's second law to find the total acceleration. Our object has a mass of 500 grams, and we know from Newton's second law, net force equals mass times acceleration. So in the x-axis, the sum 50 newtons will equal our 500 grams times our x acceleration. One small quirk. Grams is technically the base unit of mass. But for reasons that scientists are still debating, physicists and all of the formulas that physicists use are designed to take kilograms instead of base grams. We get into fights with chemists about this. Chemists tend to work with small piles of dust measured in the grams, but physicists tend to work with things the scale of cars and planets. So I think we bumped it up to kilograms to make all the numbers smaller. What this means is whenever you are plugging a mass into a physics formula for this class, it needs to be converted to kilograms first. Very specifically, the unit of force that is newtons, 1 newton is designed as the force required to accelerate 1 kilogram of mass at 1 meter per second squared. So all of our units, all of our formulas are designed for kilograms. That means instead of 500 grams, we will plug in 0.5 kilograms. And that makes our final x acceleration, should be 100 meters per second squared. We do the same thing in the y, negative 25 equals half a kilogram, and the y should be negative 50 meters per second squared. So this definitively tells us the box is going to move this way and down at the same time. It'll currently move in both directions at once. It'll favor the x, so it'll probably drift this way. But, yeah, this seems right. Questions so far? All right, so we'll continue with this on Wednesday. Your priorities for today are 1, lab if you have Monday lab, and 2, finishing out your chapter 1 homework and quiz. Send me your questions, find me in my office, or email me. Thank you all. Have a wonderful day.
So,
Feel free to set up right here and we'll take a look. I'm just going to get the camera. Yes.